SQL injection.
SQL injection is a code injection technique, used to attack data-driven applications, in which malicious SQL statements are inserted into an entry field for execution. SQL injection must exploit a security vulnerability in an application's software, for example, when user input is either incorrectly filtered for string literal escape characters embedded in SQL statements or user input is not strongly typed and unexpectedly executed. SQL injection is mostly known as an attack vector for websites but can be used to attack any type of SQL database. In a 2012 study, security company Imperva observed that the average web application received 4 attack campaigns per month, and retailers received twice as many attacks as other industries.
History.
The first public discussions of SQL injection started appearing around 1998. For example, a 1998 article in Phrack magazine. In 2013 Emperor Black Hat performed SQL injection attacks for educational purposes that had never been done before.
Forms.
SQL injection, SQLI, is considered one of the top 10 web application vulnerabilities of 2007 and 2010 by the Open Web Application Security Project. In 2013, SQLI was rated the #1 attack on the OWASP Top 10. There are 5 main subclasses of SQL injection. Classic SQLI, blind or inference SQL injection, database management system specific SQLI, compounded SQLI, SQL injection plus insufficient authentication, SQL injection plus DDoS attacks, SQL injection plus DNS hijacking, SQL injection plus XSS. The stormworm is one representation of compounded SQLI. This classification represents the state of SQLI, respecting its evolution until 2010. Further refinement is underway.
Technical implementations. Incorrectly filtered escape characters.
This form of SQL injection occurs when user input is not filtered for escape characters and is then passed into a SQL statement. This results in the potential manipulation of the statements performed on the database by the end user of the application. The following line of code illustrates this vulnerability. This SQL code is designed to pull up the records of the specified username from its table of users. However, if the username variable is crafted in a specific way by a malicious user, the SQL statement may do more than the code author intended. For example, setting the username variable as or using comments to even block the rest of the query. There are 3 types of SQL comments. All 3 lines have a space at the end. Renders one of the following SQL statements by the parent language. If this code were to be used in an authentication procedure, then this example could be used to force the selection of a valid username because the evaluation of 1 equals 1 is always true. The following value of username in the statement below would cause the deletion of the users table as well as the selection of all data from the user info table, in essence revealing the information of every user, using an API that allows multiple statements. This input renders the final SQL statement as follows and specified. While most SQL Server implementations allow multiple statements to be executed with one call in this way, some SQL APIs such as PHP's MySQL query function do not allow this for security reasons. This prevents attackers from injecting entirely separate queries, but doesn't stop them from modifying queries.
Incorrect type handling.
This form of SQL injection occurs when a user-supplied field is not strongly typed or is not checked for type constraints. This could take place when a numeric field is to be used in an SQL statement, but the programmer makes no checks to validate that the user-supplied input is numeric. For example, it is clear from this statement that the author intended a variable to be a number correlating to the id field. However, if it is in fact a string, then the end user may manipulate the statement as they choose, thereby bypassing the need for escape characters. For example, setting a variable to will drop, delete, the user's table from the database, since the SQL becomes
blind SQL injection.
blind SQL injection is used when a web application is vulnerable to an SQL injection but the results of the injection are not visible to the attacker. The page with the vulnerability may not be one that displays data but will display differently depending on the results of a logical statement injected into the legitimate SQL statement called for that page. This type of attack can become time-intensive because a new statement must be crafted for each bit recovered. There are several tools that can automate these attacks once the location of the vulnerability and the target information has been established.
Conditional responses.
One type of blind SQL injection forces the database to evaluate a logical statement on an ordinary application's screen. As an example, a book review website uses a query string to determine which book review to display. So the URL http://books.example.com/showreview.php?id=5 would cause the server to run the query, from which it would populate the review page with data from the review with ID 5, stored in the table book views. The query happens completely on the server. The user does not know the names of the database, table, or fields, nor does the user know the query string. The user only sees that the above URL returns a book review. A hacker can load the URLs http://books.example.com/showreview.php?id=50r1=1 and http://books.example.com/showreview.php?id=5 and 1=2, which may result in queries, respectively. If the original review loads with the 1=1 URL and a blank or error page is returned from the 1=2 URL, and the return page has not been created to alert the user the inputs is invalid, or in other words, has been caught by a input test script, the site is likely vulnerable to a SQL injection attack as the query will likely have passed through successfully in both cases. The hacker may proceed with this query string designed to reveal the version number of MySQL running on the server, http://books.example.com/showreview.php?id=5 and substring, version 1 =4, which would show the book review on a server running MySQL 4 and a blank or error page otherwise. The hacker can continue to use code within query strings to glean more information from the server until another avenue of attack is discovered or his or her goals are achieved.
Second-order SQL injection.
Second-order SQL happens when submitted values contain SQL injection attacks that are stored instead of executed immediately. In some cases, the application may correctly encode a SQL statement and store it as valid SQL. Then, another part of that application without controls to protect against SQL injection might execute that stored SQL statement. This attack requires more knowledge of how submitted values are later used. Automated web application security scanners would not easily detect this type of SQL injection and may need to be manually instructed where to check for evidence of second-order SQLI.
Mitigation. Parameterized statements.
With most development platforms, parameterized statements that work with parameters can be used, sometimes called placeholders or bind variables, instead of embedding user input in the statement. A placeholder can only store a value of the given type and not an arbitrary SQL fragment. Hence the SQL injection would simply be treated as a strange, and probably invalid, parameter value. In many cases, the SQL statement is fixed, and each parameter is a scalar, not a table. The user input is then assigned, bound, to a parameter.
Enforcement at the coding level.
Using object relational mapping libraries avoids the need to write SQL code. The ORM library in effect will generate parameterized SQL statements from object-oriented code.
Escaping.
A straightforward, though error-prone, Way to prevent injections is to escape characters that have a special meaning in SQL. The Manual for an SQL DBMS explains which characters have a special meaning, which allows creating a comprehensive blacklist of characters that need translation. For instance, every occurrence of a single quote in a parameter must be replaced by 2 single quotes to form a valid SQL string literal. For example, in PHP it is usual to escape parameters using the function mysqli real escape string before sending the SQL query. Note: mysql is deprecated, and should be avoided. mysqli is preferred. This function, that is mysql real escape string, calls MySQL's library function mysql real escape string, which prepends backslashes to the following characters: \xoo, \n, \r, and \x1a. This function must always, with few exceptions, be used to make data safe before sending a query to MySQL. There are other functions for many database types in PHP such as pgescapestring for PostgreSQL. There is, however, one function that works for escaping characters, and is used especially for querying on databases that do not have escaping functions in PHP. This function is @/ string $str. It returns a string with backslashes before characters that need to be quoted in database queries, etc. These characters are single quote, double quote, backslash, and NUL, the null byte. Routinely passing escaped strings to SQL is error-prone because it is easy to forget to escape a given string. Creating a transparent layer to secure the input can reduce this error-proneness, if not entirely eliminate it. IN.NET Framework just use parameterized query or stored procedure using parameters. In this case, if for example username 1 equals or 1 equals 1, this will not succeed.
Pattern check.
Integer, float or Boolean parameters can be checked if their value is valid representation for the given type. Strings that must follow some strict pattern, date, UUID, alphanumeric only, etc. can be checked if they match this pattern.
Database permissions.
Limiting the permissions on the database logon used by the web application to only what is needed may help reduce the effectiveness of any SQL injection attacks that exploit any bugs in the web application. For example, on Microsoft SQL Server, a database logon could be restricted from selecting on some of the system tables, which would limit exploits that try to insert JavaScript into all the text columns in the database.
Examples.
In February 2002, Jeremiah Jacks discovered that Guess.com was vulnerable to an SQL injection attack, permitting anyone able to construct a properly crafted URL to pull down 200,000 plus names, credit card numbers and expiration dates in the site's customer database. On November 1, 2005, a teenage hacker used SQL injection to break into the site of a Taiwanese information security magazine from the Tech Target Group and steal customers' information. On January 13, 2006, Russian computer criminals broke into a Rhode Island government website and allegedly stole credit card data from individuals who have done business online with state agencies. On March 29, 2006, a hacker discovered an SQL injection flaw in an official Indian government's tourism site. On June 29, 2007, a computer criminal defaced the Microsoft UK website using SQL injection. UK website The Register quoted a Microsoft spokesperson acknowledging the problem. In January 2008, tens of thousands of PCs were infected by an automated SQL injection attack that exploited a vulnerability in application code that uses Microsoft SQL Server as the database store. In July 2008, Kaspersky's Malaysian site was hacked by a Turkish hacker going by the handle of Mostid, who said to have used an SQL injection. In February 2013, a group of Maldivian hackers hacked the website UN Maldives using SQL injection. In May 28, 2009, anti-US Hackers infiltrate Army servers. Investigators believe the hackers used a technique called SQL injection to exploit a security vulnerability in Microsoft's SQL Server database to gain entry to the web servers. Mostat is known to have carried out similar attacks on a number of other websites in the past, including against a site maintained by internet security company Kaspersky Lab. On April 13, 2008, the Sexual and Violent Offender Registry of Oklahoma shut down its website for routine maintenance after being informed that 10,597 Social Security numbers belonging to sex offenders had been downloaded via an SQL injection attack. In May 2008, a server farm inside China used automated queries to Google's search engine to identify SQL Server websites which were vulnerable to the attack of an automated SQL injection tool. In 2008, at least April through August, a sweep of attacks began exploiting the SQL injection vulnerabilities of Microsoft's IIS web server and SQL Server database server. The attack does not require guessing the name of a table or column, and corrupts all text columns in all tables in a single request. An HTML string that references a malware JavaScript file is appended to each value. When that database value is later displayed to a website visitor, the script attempts several approaches at gaining control over a visitor's system. The number of exploited web pages is estimated at 500,000. On August 17, 2009, the United States Department of Justice charged an American citizen, Albert Gonzalez, and two unnamed Russians with the theft of 130 million credit card numbers using an SQL injection attack. In reportedly the biggest case of identity theft in American history, the man stole cards from a number of corporate victims after researching their payment processing systems. Among the companies hit were credit card processor Heartland Payment Systems, convenience store chain 7-Eleven, and supermarket chain Hornaford Brothers. In December 2009, an attacker breached a Rocky plaintext database containing the unencrypted usernames and passwords of about 32 million users using an SQL injection attack. On July 2010, a South American security researcher who goes by the handle CH Russo obtained sensitive user information from popular BitTorrent site The Pirate Bay. He gained access to the site's administrative control panel and exploited a SQL injection vulnerability that enabled him to collect user account information, including IP addresses, MD5 password hashes and records of which torrents individual users have uploaded. From July 24 to 26, 2010, attackers from Japan and China used an SQL injection to gain access to customers' credit card data from Neobit, an Osaka-based company that runs a large online supermarket site. The attack also affected 7 business partners including supermarket chains Izumi Company, Maruetsu Incorporated, and Ryukyugisco Company. The theft of data affected a reported 12,191 customers. As of August 14, 2010, it was reported that there have been more than 300 cases of credit card information being used by third parties to purchase goods and services in China. On September 19 during the 2010 Swedish general election, a voter attempted a code injection by handwriting SQL commands as part of a write-in vote. On November 8, 2010, the British Royal Navy website was compromised by a Romanian hacker named Ting Code using SQL injection. On February 5, 2011, HBGARY, a technology security firm, was broken into by LultSec using a SQL injection in their CMS-driven website. On March 27, 2011, mysql.com, the official homepage for MySQL, was compromised by a hacker using SQL blind injection. On April 11, 2011, Barracuda Networks was compromised using an SQL injection flaw. Email addresses and usernames of employees were among the information obtained. Over a period of 4 hours on April 27, 2011, an automated SQL injection attack occurred on Broadband Report's website that was able to extract 8% of the username-password pairs, 8,000 random accounts of the 9,000 active and 90,000 old or inactive accounts. On June 1, 2011, hacktivists of the group LultSec were accused of using SQLI to steal coupons, download keys, and passwords that were stored in plaintext on Sony's website, accessing the personal information of 1 million users. In June 2011, PBS was hacked, mostly likely through use of SQL injection. The full process used by hackers to execute SQL injections was described in this Imperva blog. In May 2012, the website for Worm Online, a massively multiplayer online game, was shut down from an SQL injection while the site was being updated. In July 2012, a hacker group was reported to have stolen 450,000 login credentials from Yahoo. The logins were stored in plaintext and were allegedly taken from a Yahoo subdomain, Yahoo Voices. The group breached Yahoo's security by using a union-based SQL injection technique. On October 1, 2012, a hacker group called Team Ghost Shell published the personal records of students, faculty, employees, and alumni from 53 universities including Harvard, Princeton, Stanford, Cornell, Johns Hopkins, and the University of Zurich on pastebin.com. The hackers claimed that they were trying to raise awareness towards the changes made in today's education, bemoaning changing education laws in Europe and increases in tuition in the United States. On June 27, 2013, hacker group Red Hat breached Istanbul administration site. They claim that they've been able to erase people's debts to water, gas, internet, electricity, and telephone companies. Additionally, they published admin username and password for other citizens to log in and clear their debts early morning. They announced the news from Twitter. On November 4, 2013, hacktivist group Raptor Swag allegedly compromised 71 Chinese government databases using an SQL injection attack on the Chinese Chamber of International Commerce. The leaked data was posted publicly in cooperation with Anonymous. On March 7, 2014, officials at Johns Hopkins University publicly announced that their biomedical engineering servers had become victim to an SQL injection attack carried out by an anonymous hacker named Hookie, and aligned with hacktivist group Raptor Swag. The hackers compromised personal details of 878 students and staff, posting a press release and the leaked data on the Internet.
In popular culture,
Unauthorized login to websites, that is hacking, by means of SQL injection forms the basis of one of the subplots in J.K. Rowling's novel The Casual Vacancy, published in 2012. The minor XKCD character Robert Drop Table Students, also known as Little Bobby Tables, was named to carry out a SQL injection.